The experiment we are going to perform today is series LR circuit to determine the value of inductor. As you can see the circuit diagram, in the circuit diagram the inductor and resistor, inductor is denoted by L and resistor is denoted by R. So they are connected in series, that's why it is called as LR circuit. So they are connected in series. There is a signal generator here, then a voltmeter is connected in parallel to the signal generator, and a current meter, AC current meter, is connected in series. So this is the circuit diagram, and you can first arrange the apparatus according to the circuit diagram. This is the inductor, this is the resistor, this is the signal generator, and this is the voltage source, and this is the AC ammeter. After doing the connections, then only you will switch on the circuit. After switching on the circuit, you have to take down the observations and readings. As you can see, once we put the circuit on, some current may flow in the circuit or not flow. It depends on the value of resistor. So first we will take out the value of 100 ohms from the resistance box. Then we will adjust the signal generator frequency to 50 Hz. Also you can see in the voltmeter the voltage is not adjusted. So we can adjust the voltage to around 4 volts or 5 volts. So you have to keep this voltage constant. You can keep it 4 volts. So now we will be keeping it 4 volts voltage and frequency as 50 Hz. And we have also kept the resistance as 100 ohms. Accordingly, the current will come on the ammeter. What is L? L is your inductor. So this is the inductor which is given to you. Then what is R? R is the resistor. So this is the resistance box which is given to you. Now you have to do the connections according to the circuit diagram. So this is the circuit diagram which is given to you. Now arrange the apparatus according to the circuit diagram. So you can see it is having a signal generator which is shown here. Then the next is milliammeter, which is a series, which is a AC milliammeter. This is your inductor, this is the resistance box, and this is the voltmeter. Once you have arranged the apparatus according to the circuit diagram, you start doing the connections. From the source or signal generator, connect a wire to the milliammeter, one terminal. Then the second wire from the milliammeter is connected to the inductor, which is here. Then the second terminal of the inductor is connected to the resistance box. Always take out one key and keep from the resistance box as a precautionary measure. The second terminal of the resistance box is connected back to the source. So this is your series connection. The voltmeter has to be connected in parallel always to the signal generator. So one terminal is going to this, the second terminal is going to this terminal of the AC signal generator. Always check whether you have kept the signal on AC signal only. So there is a switch here which shows square wave and sine wave. You have to press the sine wave. Then you can see there is a knob which is showing you multiplier 10, multiplier 100, and here it is written sine square wave generator and frequency. So you can adjust this frequency by using this knob. Multiplied by 10 means if it is kept on 4 multiplied by 10 is 40 Hz. If it is on 100, it is 400 Hz. So you keep on 10 and adjust to approximately 5. So it will be 50 Hz. So frequency you have adjusted to 50 Hz. Once you have done the connections, then only put the switch on. Once you put it on, this light will glow. As soon as this light glows, you know the circuit is on. So some current will flow in the circuit and some voltage will flow in the circuit. You adjust this knob so that the voltage shown will be 4 volts. Once you have adjusted this to 4 volts, throughout the experiment, this voltage will remain constant. Now, as you have tabulated, you have to tabulate the readings in the tabular form. The resistance R is 100 ohms. The current which is shown on this milliammeter, current is 5.8 milliamps. Then you can note down this in the observation column. Now when you take the next reading, you will take 200 ohms as shown. So this is 200 ohms. As you can see, the current has decreased. Voltage is remaining the same. So note down the reading of current and the reading of the resistance. Like this, you go on changing the resistance. This is 300, 400. You can see the current goes on decreasing. There are minor changes in the voltage, but you don't have to do anything. You just keep it as it is. Just write down the values of resistance as well as current, and then you have to do the further calculations. Now, in the observation table, you will write the voltage value which is given, that is 4 volts, frequency which is 50 hertz. Throughout the experiment, these two quantities will remain the same. Then the readings are tabulated in the format showing below, that is resistance in first column, second column is current in milliamps, then third column is current in amperes. How will you convert milliampere into ampere? 10 raised to minus 3. You have to multiply by 10 raised to minus 3. Next column is Z, which is called as impedance, which is given by the voltage upon current in ampere. Then the next column is R square and the next column is Z square. So the calculation part you have to do using simple calculator. Now when you take the next reading after 100 ohms, you will take 200, 300, 400, like this you will tabulate your readings till 10 readings. The current will go on changing, it will go on decreasing, and then do the calculations accordingly. After doing the calculations, you have to plot a graph of Z square against R square. Z square is taken on Y axis, R square is taken on X axis. You will get a straight line graph which is having an intercept on the Y axis. So that value is called as XL, which is called as reactive inductance. From this value, you can calculate the value of inductance using this formula. L is equal to square root XL square upon 2 pi F. Today we will be doing the experiment series CR circuit to find the capacity of a capacitor. The circuit diagram for this experiment is as shown. The capacitor and resistor, they are connected in series. Then again we require a signal generator for getting the supply. A voltmeter is connected in parallel to the signal generator, and there is an AC millimeter which is in series. Now you have to arrange the apparatus according to the circuit diagram and do the connections. Now you have done the connections. First, don't put the supply on. You will put the supply only after completing the connections. Again you have to adjust the voltage in the signal generator to around 3 volts and frequency to 50 hertz. You have to tabulate the readings in the tabular form as shown below. The first column is for resistance, second is for current in milliampere, third column is current in ampere, then the impedance which is given by V by I, then R square and Z square. Here also you have to write on the top of the table the voltage which you have applied, that is V is equal to 3 volts, frequency is equal to 50 hertz, and then change the resistance from 100 ohms onwards. For every reading of resistance you have to note down the value of current. It will go on decreasing. For the first reading the current will be maximum, for the last reading the current becomes minimum. So you have to tabulate this in the tabular form. After doing the calculations, you have to plot a graph of Z square versus R square as shown in the figure. It will have an intercept on the y axis which will give you Xc square, which is the reactive capacitance. By using this formula you can substitute the value and find out the value of capacitance. Same experiment can be done for a series CR circuit. What you have to do is, just instead of this L you will replace it by this capacitor which is C, and the same procedure is followed.